We're over here in this chapter section of proof by mathematical induction. And mathematical induction is a method of proving statements using or involving natural numbers. Now, I'm going to make a confession to you. I find this hard to get my head around at times. And I think a part of it is because what this series right here actually is, and that's kind of what throws me off. But with mathematical induction, there's 3 steps, and the first step is to show that the statement is true when n equals 1. So if I look at this first number here, and the first number is 1, if I put in 1 for n, is it going to equal 1? So let's do that first. So I got 2 times, I'm going to substitute 1, first number in the series, minus 1 equals n squared. Well, 2 times 1 is 2, minus 1. I should put a 1 squared here, so 1 squared. And so 1 is equal to 1. So we're going to say then that the statement is true. I'm going to go one step further here, and I think this is the part that gets me confused. When I put in the second number of the sequence, which is 3, it's actually going to equal 1 plus 3. Does that equal 2 squared? Well, it does. 4 is going to equal to 4. And if I put in 3 into 2n minus 1, I'm sorry, if I put in 2, second number of the sequence, is that going to equal 3? Well, 2 times 2 is 4, minus 1, well, that does equal 3. And 3 plus 1 equals 2 squared. Well, what about if I put in the 5? So if I say that the third number of the sequence is this defined as 2 times 3 minus 1, well, 2 times 3 is 6 minus 1, well, that equals 5, okay, that's fair enough, there's the 5. But what does 1 plus 3 plus 5, does that equal 3 squared? Well, 1 plus 3 plus 5 is 9, and 3 squared also is 9. And so it's that 1 plus 3 plus 5 that throws me off. But let's move on to the second step. Now, the second step says that we assume that the statement is true for some natural number k. And we call this the induction hypothesis. And we would actually write this as 1 plus 3 plus 5 times 2. Let's see how that was written again. 2 times k. Well, wait a minute. Yeah, 2k minus 1. 2k minus 1 equals k squared. That's called the induction hypothesis. And now let's move over here to step 3. Step 3 says that we show that the statement is true for the next natural number, k plus 1. And so here we've got 1 plus 3 plus 5 plus plus k plus 1 plus the next natural number, 2 times k plus 1 minus 1. And is that going to equal k plus 1 squared? Now, we had already determined in our induction hypothesis that this portion right here was equal to k squared. And so what we're trying to prove then is that this right here, which is k squared plus 2 times k plus 1 minus 1, is that going to equal k plus 1 squared. So let's solve the left side of this and see if it proves to equal what the right side is. Well, let's see. Then we've got k squared plus 2k plus 2 minus 1. And let's combine like terms, and we got k squared plus 2k equal plus 1. All right, I got a quadratic equation here, which I can factor. To k plus 1 times k plus 1, which is the same as k plus 1 squared, because those terms are the same. And so we have proved that the original statement, 1 plus 3 plus 5 plus 2n minus 1 is equal to n squared. Now, if you don't think this is fun, you have not lived. But of course, as I confess, this is really hard for me to get my head around. And I'm not sure that even after shooting this video, I got it any better. But hey, I tried.